Excuse me, are you the pig of wisdom?
One of the pigs of wisdom. There are 9 of us in total. I am the wise pig of the mineral moon. I can tell you all about chemistry.
Well, I'm a little pig who's trying to help Emily with her schoolwork, and I was hoping that the pig of wisdom could help us out. Perhaps you'd help us to learn some chemistry.
I'd be delighted. People don't often ask the pigs of wisdom for help these days. Let's go for a walk around the mineral moon and see what we come across.
Oh, is that limestone over there? It's calcium carbonate, isn't it?
Yes, it is. It's very useful for building things. It's an important ingredient in cement, mortar, and concrete.
Oh, eroded by acid rain.
That's right. We don't have acid rain up here on the mineral moon, but down on Earth, gases like sulfur dioxide can form acid rain. The acid reacts with the calcium carbonate and makes it start to disintegrate.
That's a shame. I bet you're glad to be up here on the mineral moon. So what happens to the limestone if we heat it up? I heard something about a thing called thermal decomposition.
Well, yes, little pig. Thermal decomposition will happen if you heat up calcium carbonate. A strong heat will release carbon dioxide from the limestone, leaving just calcium oxide as a solid.
Is calcium oxide any use?
Yes, it is. If you add water to it, you can make calcium hydroxide, which is also called slaked lime. That's really useful for farmers to spread on fields if they have acidic soil.
I heard that you can use it to test for carbon dioxide.
Goodness, you have heard a lot about chemicals. Yes, if you dissolve lots of slaked lime in water, you make lime water. If you pipe carbon dioxide through it, it will react with the calcium hydroxide, and little bits of white limestone will be formed, which makes the water look cloudy. It's a really useful test to find out whether something is giving off carbon dioxide.
Thanks. I'll make sure to remember that. Lime water, carbon dioxide, goes white, cloudy, little bits of calcium carbonate. Cool. Hey, look over there. Is that some iron ore over there?
Well, yes, it certainly is. How did you know that?
Well, never mind, but we like to make things out of metal. Metal's really useful, but it's really hard to get out of the ground, isn't it?
Yes, it is. If a metal is not very reactive, like gold or silver, you can sometimes find it in the ground, but most metals are more reactive and are found as ores. An ore is normally an oxide of the metal stuck in a lump of rock.
So that iron ore over there is iron oxide mixed up with a load of rock?
That's basically right. Because iron is still fairly low down the reactivity scale, you can extract it from the ore by heating it up with carbon.
Ooh, that sounds like fun.
Well, it's not exactly fun, but it is very hot. You need a blast furnace to heat up the iron ore and coke with hot air.
You use coke?
No, not the drink, no. It's coke that's a nearly pure form of carbon.
Okay, well, at least that means there's more left for me to drink.
Yeah, don't drink too much of it. It's not good for you.
Okay, anyway, so what happens to the iron oxide rock and the carbon? Do the chemicals react when it gets really hot?
Well, yes, that's exactly what happens. Removing oxygen is called reduction. Carbon is more reactive than iron, so when we heat it up, it reacts with the oxygen from the iron oxide and leaves us with liquid iron. The carbon has also reacted with oxygen from the air to form carbon monoxide, and this reacts with the iron oxide as well to form carbon dioxide.
So that's it. We have iron oxide plus carbon makes carbon dioxide plus iron.
Basically, yes. There are other things going on too. There's limestone in the blast furnace.
Limestone again? Wow, that's really useful for all sorts of things, isn't it?
Yes, it certainly is. It reacts with some of the other impurities in the ore and the rock to form a yucky thing called slag, which floats to the top of the liquid iron. We can drain that off the top, and then we're left with some fairly pure iron at the end of it. We need to cool it down before we can use it, though, because it's really hot.
Iron oxide plus carbon and carbon monoxide makes iron plus carbon dioxide. Okay, well, that's still pretty neat. And that kind of reaction is called a reduction because you are taking oxygen away. Fine. So what do you call it when you add oxygen to something? Adding oxygen is called oxidation. Taking away oxygen is called reduction. Okay, that's really helpful. So can you extract other types of metals from their ores with a blast furnace and some carbon?
Well, not all of them, I'm afraid. Lots of other useful metals are more reactive than carbon, so that reaction wouldn't work.
Oh, that's a shame. I heard copper is a really useful metal because it conducts heat and electricity well, and it's nice and bendy. Can we get copper by reducing it with carbon? Up to a point, yes. Copper is less reactive than carbon, so we can reduce it with carbon, but we end up with impure copper. To get pure copper, we need to purify it with electrolysis. Electrolysis? That sounds painful. Don't worry, it doesn't hurt the copper. So, what happens? Do we electrocute impure copper to make it purer? Sort of. We make positive electrodes out of the impure copper and put them in a solution of copper sulfate. We pass electricity through it, making pure copper ions. That's like copper atoms, but with 2 electrons missing, so it has a positive charge. These positive ions are attracted to the negative electrode, where they gain their 2 electrons back and become pure copper atoms. Meanwhile, the impurities that were in the copper will fall to the bottom of the copper sulfate solution. We have lots of lovely pure copper. Well, that sounds simple. Are you sure about that? Well, it's not exactly simple, and it's quite expensive, but it sounds as though you're getting the hang of it. So, what about iron and steel? What's the difference between them? I don't already understand that one. Well, I'm glad you've asked me that, little pig. Steel is a mixture of iron and carbon. The carbon helps to make it harder. Most metals are soft in their natural state, so you have to add other things to them to make them harder. You can make lots of different alloys. An alloy is a mixture of 2 metals, or maybe a metal and a non-metal together to form a different substance. You can add things to make them harder, or bendier, or more resistant to rust. There are lots of useful things you can do with alloys. Oh, that's good, because I wouldn't want to be using a rusty knife or fork. Yes, well, you don't have opposable thumbs, so you'd struggle to use any kind of knife or fork. Yeah, that's true, but Emily does. Exactly, and we wouldn't want her to have a rusty fork. That's why we make forks from stainless steel. It's a special mixture of iron and carbon and a couple of other things that make it extra good at not getting rusty. It's really good for making cutlery. They used to make it at Pond's Forge in Sheffield. Really? That's where Emily used to go for karate tournaments. That's right. It used to be a place where they made lots of iron and steel. So, steel isn't an element then? No, steel is an alloy, like I said. It's a material that's made up of 2 or more elements. At least one of those elements will be a metal. Okay, that's great. I understand alloys now. So, what about metals that are more reactive than carbon? We can't use carbon to reduce the ore into the oxide and the pure metal, so what do? Well, we have to use electrolysis. Oh, that painful thing we did with copper? Well, sort of, but at much higher temperatures usually. Aluminium's a really useful metal. Its ore is called bauxite. Oh, that's a stupid name. Yes, fair point, it is a stupid name, but bauxite is what it's called, aluminium oxide mixed up in a load of rock with a bunch of other impurities. Anyway, to get aluminium, you need to make very hot molten aluminium oxide and then put positive and negative electrodes in it and charge electricity through. Just like when we were purifying copper, the aluminium atoms will lose some electrons. They'll become positively charged aluminium ions, which are attracted to the negative electrode. They all gather on the negative electrode, and we've got our aluminium. Sounds simple, but it's very expensive. It takes a lot of energy. Well, thanks, Wise Pig. I've learned a lot about elements today. I'd better go back and tell Emily about it. But I'll be back to learn some more things later. Please come back soon. So, limestone, calcium carbonate, slaked lime, testing for carbon dioxide. That one's important. And then there's metal ores. Ores are usually an oxide of the metal trapped in some rock. If a metal is less reactive than carbon, we can extract it from the ore by heating it up with carbon and letting the carbon take away the oxygen to form carbon dioxide. And for metals that are more reactive than carbon, like titanium or aluminium, we need to use electrolysis, and electrolysis is expensive. Okay, I've got it. Good luck, Emily. I hope we get this right.